This is a Java developer roadmap for 2026, and contrary to the previous roadmaps, this one is for other people. This one is for those of us who only begins, who wants to choose a language, and who probably wants to understand what will they need to learn before they will become an actual Java developer in enterprise. Obviously, it is impossible to learn everything in this video in 1 year, but you can totally learn basics and you can get a general understanding of many other topics. Also, this roadmap hopefully will provide you with some materials you could use while learning and actually some future perspective. Hi, my name is Pasha. I'm a developer advocate for Belsoft, and I'm more than 15 years in Java development. And I wish I had something like this video at the beginning of my career. We will have a PDF version of this roadmap published down below in the description, so if you don't have time or you forgot about the video, you can always get back to the PDF version of roadmap and see what's ahead. I've split this roadmap into 8 levels, like an arcade game, and you might find that the last of them is much more complicated than the first one, even though starting is usually the hardest part. So let's start from the first level, fundamentals. Everything obviously starts with syntax. You should learn variables, functions, what are data structures, what are operators, what is control flow, for example, loops, ifs, elses, and so on. And you should know such a basic structure as array. Then, after you know the basics, you will go to safety. And safety is essentially about 2 things in Java. First, it's about exceptions, how you should throw them and how you should handle them. And second, it's about class path. Class path is exceptionally important in Java. Class path defines what is available inside your application and what is loaded in there. After you learn the syntax basics, you're moving to core toolchain, Java command, JavaC command, and many others included into JDK. Then, if you don't know what OOP, object-oriented programming, yet, you will have to learn it to understand the idea of class, to understand 4 pillars of object-oriented programming: encapsulation, inheritance, polymorphism, and abstraction. And in Java, you will also have to understand the difference between statics and instance methods. If you need a reference material for this level, you want to look at the book by K. Horstman called Code Java. The book is immense, it's huge, probably even reading it is longer than a year, but you don't need it fully. You need only parts you're currently interested in. If you hesitate which number type you should use, look at Code Java. If you don't know what runnable is, look at Code Java. It has a lot of answers, but it doesn't mean that you should remember them all by heart. This book also covers the level 2. Let's jump to it. Level 2 is standard library. Standard library starts for you from collection framework. You need to know what are lists, sets, maps, and what are generics. They're used everywhere in the collection framework. After that, you probably would like to learn about modern Java, because Java 25 is significantly different from Java 8, and you would like to learn about lambdas, stream API, optionals, and records. Now, there are several essential APIs you should know too. For example, you should know about string builder, file IO, and file new IO. You should know datetime API and math, probably the main class to work with mathematics abstractions. If you need more books at this point, I have one more for you. Book Effective Java tells you a lot how to use these things correctly. So you won't be blind going into selection between list and set. You will know exactly what you are doing. Now, I have to say, If you really mastered level 1 and level 2, you're already an amazing Java developer. You know how to use Java, you know how to use it properly, and probably you could solve almost any task with it. But still, development world is so much more than just writing the code, right? We should build the code, we should ship the code, and so on. And level 3, development and build tools, is about your mastery in tools. And obviously, you should know build systems for Java. Currently, there are 2 main systems. It's Maven and Gradle. There are others like Bazel, but they're much less popular, so probably you don't need to spend time on them. Obviously, you can't write code in enterprise without using version control, so you have to use Git. Git is everything and it's everywhere. And the main hosting for Git is either GitHub or GitLab these days. Many companies have their own storages, but if you know GitHub, you already can work with the whole or almost whole Java open source ecosystem, which is an amazing entry to your career. Then, to actually write a code outside of Notepad++, you should probably use an IDE. You will be much more comfortable with it. And in my opinion, there is only one IDE you should look at. It's IntelliJ IDEA. It is free for personal use, and it will allow you to do all the things you need to do with Java. And also, refactoring and debugging capabilities of IntelliJ IDEA are just amazing. There are many talks about it, just look at them. If you need more reference literature, then for Git, you have to read Git SCM book. For other things like Maven, Gradle, IDEA, you probably would like to read reference documentation. Now, when you know all the basics, we can move to advanced topics. Obviously, most part of modern enterprise software couldn't live without database systems. And usually we are talking about relational databases, so you should learn them. You should have an understanding what SQL is, what is create, update, select, delete, insert, and so on. When you have this understanding, you will be able to use JDBC, which is Java Database Connectivity. It's a layer of Java which allows you to universally work with almost any relational database. And then you would probably prefer to dive into ORMs, Object Relational Mapping. It's a very interesting concept. It kinda allows you to abstract from database. You won't ask, Pasha, but you just said we have to know our databases. Yes, and that's why you don't start with Hibernate. That's why you start with JDBC and SQL to understand how roughly Hibernate works under the hood, to be able to debug if something goes wrong. As always, I have a book to recommend to you regarding this topic. Read Java Persistence with Hibernate. It's an amazing book about Hibernate and how to use it in production. Also, for Hibernate and for all the databases, please refer to their reference manuals. It would be virtually impossible to write a huge enterprise application like probably your bank has without knowledge of enterprise web stack. So this is our next level, level 5. First, you have to learn about dependency injection and inversion of control. This is probably the cornerstone of the whole enterprise software written in Java. After that, you would like to learn into several projects. Mostly you are interested in Spring, particularly Spring Web to create web applications, Spring Data to work with databases and different storages, and Spring Security, because every application should be secure, especially enterprise ones. Or probably you would like to look into Jakarta EE, which used to be Java standard back in the day. It's not anymore, but it's still developing rapidly. And of course, there are counterparts of Spring things there for web persistence and security. And also, there are many other frameworks, smaller ones, not that popular, like Quarkus, like Micronaut, maybe Juby. You can look at them. But When you know basics of Spring, and probably not only basics, but some of the more advanced topics too, you're essentially good to go. You can learn everything else when you need it. To be honest with you, I have never read a book on Spring, but I know that Spring in action is good, and also reference manuals for all the Spring technologies are amazing. But you know what? It's not important how good do you know Java or how well do you know Spring. What is important, everyone makes bugs. Yes, me too. Yes, everyone. And to fight bugs, we need to be able to write tests. So this is our next level, level 6, testing and code quality. It all starts with unit testing. The main framework for unit testing in Java is JUnit, and you will also need to know a couple of additional ideas about unit testing. You will need to know what is mocking and what is faking. Then after unit testing, you also need to know about integration testing. There is a huge argument, what do we call integration and what is component testing? Not important. You need to know something about integration testing and how to do it in Java, probably how to do it with Spring. And after that, you probably would be curious for you to learn about advanced testing techniques, like, for example, mutation testing, or property-based testing, or behavior-driven design. This is not essential, but it might be interesting and might be very useful in some kinds of applications. After you killed all the bugs, you will have to ship your software to production. And this is our level 7, deployment. For deployment, you will need to know at least a couple of concepts. Containerization, in particular, you need to know Docker. And by the way, Docker helps a lot when you have to deploy software. You will also need to know things about CI/CD, continuous integration and continuous delivery. There are two major tools these days that are the most flexible, the most capable, in my opinion. They are GitHub Actions and Jenkins. By the way, Jenkins is written in Java. So you could notice that with levels, we abstract further and further away from Java. Level 7 almost doesn't have anything in common with Java. Yes, you need to know some things, but it is more about production than about code itself. Level 8 is different. I will only say a couple of words about level 8. Level 8 is about concurrency. Concurrency in Java is complicated. Yes, Java was created in multi-threading in mind. It is done amazingly well, but you still need to learn concurrency. Because in the package Java util concurrent, there are many concurrent data structures. They all are not trivial, or many of them are not trivial. Usually you can't just use them. You need to understand what are the trade-offs and what are the benefits. You also need to know many of them just in case, because sometimes it happens you think that you can use something, but you actually can't. It would lead to errors in your software. I won't read you a huge lecture on concurrency, it's probably too early, but when you are at this stage, I'm still there, by the way. I'm not sure if I know my concurrency perfectly. I actually know that I don't. So there is one book I can really recommend. Java Concurrency in Practice. I don't know any better book on Java concurrency, to be honest. If you mastered the level 8, first, congratulations, the princess is in another castle. Second, congratulations, you're much better than me. Because I'm not sure if I mastered them all, but I'm trying. I'm really trying almost every day. Third, if you're at this point and you still remember this video, probably at least a year have passed, come here, leave a comment, say thank you. And I will say thank you right now. Thank you for your attention. If you like the video, subscribe to the channel, drop a comment down below. And with this, Pasha out.